Hello students! So far we have learnt about different functional groups and the names, structures of the new compounds they form by combining with hydrocarbon chain such as aldehyde group, ketone group and carboxylic group. Let us go ahead and find out about a new functional group, that is ether. The ether as a functional group has just one oxygen atom, which can be joined by a single bond on both sides. Here it can bond with either two of the same hydrocarbon chains, that is alkyl groups, or two different alkyl groups on both the sides. Now wait a second student. I know you must be thinking that how a single atom can be a functional group. But students, recall that we have seen one more functional group which included single atoms. Yes, exactly. I am talking about halogen group. It included halogen atoms like chlorine, fluorine, bromine and iodine. But students, specifically, they are not halogen atoms, but they are halogen ions which act as a functional group. On the similar basis here, oxygen atom acts as a functional group since it has two electrons and it can share these electrons with the carbon atom of alkyl groups. Yes, as you can see from the structure and the electronic configuration of oxygen that it has 6 valence electrons and it requires 2 more electrons to make octet configuration, that is 8 electrons. So it can share its 2 electrons and thus form 2 bonds. It bonds with 2 different or same alkyl groups. Say for example, if the alkyl group on both the sides of oxygen is methyl, that is CH3, then the new compound is dimethyl ether. Di means 2, methyl is the alkyl group and ether is the functional group. This means this ether is bonded to 2 same alkyl groups on either side. Its formula is C2H6O. The structure or formula, which is also written as CH3OCH3. Similarly, if this ether now has one methyl group on one side and a propyl group on the other side of oxygen atom, the new compound so formed is methyl propyl ether. Its molecular formula will be C4H10O, also written as CH3O, CH2, CH2, CH3. Now comes the ester functional group. The ester functional group consists of 1 carbon and 2 oxygen molecules. It is represented as dash COO. As you can see in an ester group, the carbon atom is bound to one oxygen by a double bond and the second oxygen atom by a single bond. So out of 4 valencies of carbon, 3 are satisfied and only 1 remains to make a bond with alkyl group R. But wait, look at this structure again. What do you notice? Yes, we notice that 1 valency of oxygen is also remaining. And so, even oxygen will form bond here with the other alkyl group R dash. Again, here R and R dash can be either same or different alkyl groups. And what are you going to call these compounds? It's easy. First, write the name of alkyl group which is attached to oxygen and then add suffix OAT, which represents the ester functional group to the parent chain name. By parent chain here, I mean the carbon chain attached to the carbon atom of the functional group. For example, say the methyl group joins with oxygen and the parent chain has 2 carbons. Thus, the new compound formed is methyl ethanoate. Ethane stands for saturated hydrocarbon which has 2 carbon atoms and O8 for ethyl functional group. Its molecular formula is C3H6O2, which is written as CH3COOCH3. Students, remember that when writing the name of an ester compound, the suffix O8 is added to the chain bonded to carbon atom of the functional group. And that's why in our example, we wrote methyl ethanoate, because here ethane chain has the functional group. So what will be the name of this compound? Pause the video, think about it, and I'm sure you'll get it. Yes, the name of this compound is methylpropanoate, and the formula is C4H8O2. So far, we have seen different functional groups, their structures, and their names. In the next video, we will see about homologous series of carbon compounds.